Hi guys, welcome to my channel, and in this video I'm going to talk about some questions for work, energy and power. Okay, first we have a question here. A car of mass 1200 kg pulls a trailer of mass 400 kg up a straight road which is inclined to the horizontal at an angle alpha. Okay, so first we need to draw a diagram. It's a slope cause the straight road is inclined to the horizontal with an angle alpha, and sine alpha is 1/14. So in here you can draw two circles, and this is 1200 G. So this is the weight, which is mg, and for the trailer is 400 G. Okay, the trailer is attached to the car by a light inextensible tow bar which is parallel to the road. Okay, so there will be tension here. So tension is always directed away from the objects. Imagine we have a trailer here, and this trailer is pulled by the tow bar because it's going up the slope. So imagine if the tension is directed towards the trailer, the tow bar will not be able to pull the trailer anymore. Instead, it pushed the trailer. So it doesn't make sense at all in these questions. So the car engine works at a constant rate of 60 kilowatt. So this 60 kilowatt is actually power, which means 60,000 watt. So the K means 1000. The non-gravitational resistance to motion, which is the friction, are constant and of magnitude 1000 on the car. The friction here is 1000 on the car, and the trailer 200 trailer. First, we can use the formula for P, which is P equals to force times velocity, and force will be P divided by velocity. Okay, what is this force? This force is actually the thrust, which means this force. So force is equals to P, power, which is 60,000, divided by 10. So the force will be 6,000 Newton. Next, how do we find acceleration? We can find the acceleration by using Newton's second law, which is the resultant force is equals to ma, and we take going up to the slope as positive. Okay, so what force do we have here? Here for the car we have force F, which is the 6,000 Newton, and the friction 1000 Newton, and a component of the weight that is parallel to the slope. How do we find that? Okay, first we draw a right angle triangle, and here we have the angle alpha, and the component that going down is the weight, which is 1200 G. So here we know this is 90 minus alpha, right? Because 180 minus 90 and minus alpha, so it's 90 minus alpha. If we draw a line which is perpendicular to the slope, we will find out that this is actually alpha, which means the component that is perpendicular to the slope is 1200 G cos alpha. So which means the component that is parallel to the slope is 1200 G sine alpha, because you're going out from the angle from the alpha. So for the trailer is 400 G sine alpha. Okay, so this is the component that is perpendicular to the slope, but we don't need this, so we don't need to write it down. So now we consider C and T as an object. So we combine all the force together. First, we need to write down all the force that is going upward, which is 6,000. Okay, next is the friction, which is 1,000 plus 200 is 1,200 minus 400g plus 1,200g 1600g sine alpha equals to the total mass 1600A. Okay, so in here you will notice that I didn't write down T because the tension is in both directions, it's in opposite direction. So one of them is positive, right? And the other is negative. So since they have the same magnitude, so they will be cancelled out. 400 divided by 14 times 9.8 1120 600A. So A, which is the acceleration, is equal to 2.3 meter per second squared. Okay, for B, we need to find the tension in the tow bar at this instant. Okay, if we need to find the tension, we cannot consider both of these object or car together, because if we consider them both together, the T will be cancelled out. So we need to choose one of them to be considered. So I'll choose trailer since there are less forces there. By considering trailer, which is T, so the resultant force is equal to MA. So T minus 400g sine alpha minus 200 is equals to 400A. So T minus 480, 400. Since we found the acceleration, which is 2.3 meter per second squared, so T is equals to 400 times 2.3 plus 480, 1400 Newton. Okay, so the tow bar brakes when the car is moving at 12 meter per second. Okay, find using the work energy principle the further distance that the trailer travels before coming instantaneously to rest. Okay, so here we can redraw the diagram, but this time we only consider about the trailer. Okay, since they already say using the work energy principle, which means we must use the conservation of energy. We can't use F equals to ma, which is Newton's second law. Okay, so first we know that before the tow bar brake, it's moving with velocity of 12 meter per second. After that, it is at rest before coming instantaneous to rest. So we need to find out the distance it has moved. So we know there is a friction which is 200 Newton. Okay, now we can start constructing the equation for the conservation of energy. So before the tow bar brake, we know that it's moving with 12 meter per second. So there will be kinetic energy. And because there is a height from the ground, which we take this level as origin, so we know it has gravitational potential energy too. After that, it doesn't have kinetic energy because the velocity is 0, but it has high value of gravitational potential energy, which is the GPE final. So if you start to do calculation here, you found out that there are extra energy left. And since the kinetic energy is 0, where will the extra energy be transferred to? Here, it will be transferred to the friction, which is work done by the friction. Here we can write down half mu squared plus mgh initial. So we take this as initial, final, goes to mgh final plus friction times the distance moved, which is the W equals to F times S, the work done equation. So here we can actually find the difference in height. So which means we can simplify the equation more. So we know that the difference in height is when h final minus by h initial. So half mu squared is equals to mg, difference in height, plus f times the distance moves. Okay, so how to find the change in height? So since this is alpha, we know this is alpha 2. By using sine alpha equals to delta h divided by delta x, we know that delta h is equals to delta x sine alpha. And since sine alpha we already know is 1/14, which is given. So difference in height is delta x divided by 14. So now we have all the information. So 1/12 times the mass of trailer, which is 400, and the initial velocity is 12 square times 400 g x 14 plus the friction times distance moved. So 400 times 1.8 divided by 14, 80 x plus 200 x. 480 x. So we know it moved 60 meter.